Welcome to Data Science Now, a podcast by Closter about the latest trends in data science with your host, Fabio Vasquez. On this episode, we'll talk about the most important programming languages for data science and how to learn them. Follow us on social media at Closter Team. This is Data Science Now.
Of Data Science Now. We're here on the 7th episode, and this is a very important topic, the best programming languages in data science. So, I'm going to get started with the topics of the day. The first one, it's going to be why programming in data science. So, I've been talking about several different things in this podcast and videos, and one of them is that programming is a very important thing, but it's only a tool. We have more important things to worry when you do data science, like the context of the problem, the business understanding part, being able to get from ideas to actual problems, the part of really delivering value into a company. So I think basically I can say that programming is important for data science because we need to create data products. And most of these data products will come from you creating a system or delivering a model. Programming in data science means that you need to be able to understand programming languages, logic, and computer science to transform these ideas you have into actual solutions that can help your company or your client. So the idea of this session is for me to talk about this for in the world of programming, what you should be learning, how to learn that, and what is the important pieces you need to put together to be able to really have a good experience and a good feel about programming in your daily basis as a data scientist. Let me get started with saying again that this is a tool and this is important, and you need to spend time learning programming. It's not just you don't need to only know how to develop algorithms in machine learning and how to use pandas in or R data frames that we're going to talk about later. I mean, you really need to understand how to code, how to solve problems with programming languages. That means that you need to spend some time learning, like in the learning curve of programming, meaning that you need to learn the basic structure of a language, how to solve a problem, data structures, and all of that takes that in the understanding of a programming language. So, which programming languages are the most used right now in the world of data science? I think most of you will know the answer, and we have a top two maybe, and it's going to be Python and R. Python and R, and the continuous discussion or which one is better, which one should I be learning, and all of that. We're going to take that into a different session. But right now, those are the languages that you're going to be seeing in the interviews. They're the ones are being most used in companies, in the academia as well. So when you are in the place that you need to decide where do you want to get started with programming and data science, I think my recommendation all the time is you learn Python in the beginning because this is a full programming language. And we discussed this in the past sessions about what's Python and all of that. So if you want to watch that, remember that we have all of these sessions are recorded and they are on YouTube and Spotify as a podcast. So we have these top two languages. We have R, we have Python, but is that it? I mean, is that what we have to learn and that's it? I think right now we have to go back and think that okay, these are the most important languages we have in data science, but they're not the only ones. And a lot of big companies and people are actually using at least four more languages that can help you build different things that you may not be able to do with Python or R. And the important thing here to notice is that all of these languages have their advantage. So let me get started with a language that can be the beginning of a lot of different things we have in the world right now, and that's C++. C++ is a language that comes after C, and this is an object-oriented programming language that is extremely fast. It's one of the fastest languages we have in the programming world. And you may think, why is this important for data science? Is that sometimes you don't have everything. Not everything is programmed. Not everything is coded. Not everything is in a library. So sometimes you need to do your code. I mean, and of course you can do that in Python or R, but for C++, one of the cool things that you're taking advantage of one of the fastest languages we have in the world right now. It's not easy. It's not an easy thing to use. You need to spend a lot of time understanding the internals of C++ to be able to create these solutions. But if you go there and try to see where are the bases of all of these languages like Python and stuff like that, I think most of them come from the C++ world. Python is written in C and C++ as well. We have a lot of different libraries from R that comes from C. NumPy has C++ underneath as well, and a lot of the optimizations happening in SciPy, scikit-learn, and all of this library in Python are using C++ as well. If you go outside that and check things like Mesos, a system to distribute and take advantage of a cluster, that is written in C++ as well, and a lot of different things. So it's a language you have to understand that it's still important, and that you need to be able to at least understand the basic coding in C++. There are some things that I can recommend. I mean, they are there. If you want to learn C++, there are great books. The creator of the language has a great book called C, and the creator of C++ has a book called C++. So in there you'll find a lot of information. We also have a lot of old school videos on C++ that you can find online. Schools like Stanford, Yale, Harvard, and the MIT, they all have online lectures for free on YouTube in a whole computer science class, in like a whole semester work of videos about C++ that you can find online for free. Another language that is also a very important one for the world of data science right now, it's Julia. So Julia is a language that is new. It's kind of new. It has a few years. And it's been going steadily, and it's growing a lot, in not only in the world of data science, but in the world of scientific programming. Julia has an ecosystem for data science, and you'll find things like data frames, JuliaDB. You have the queryverse that is similar to the R tidyverse. You have Julia Graph. You can work with databases with JDBC and ODBC in Julia, and you have stuff for the Hadoop ecosystem like Hive, HDFS, and Spark with Julia as well. You also have different libraries for machine learning in Julia, like Flux. You have Net, and you have a lot of different things like automatic differentiation. You have GPU. And you can even create deep learning algorithms with Julia. One of the cool things about Julia is that it's faster than Python because it has something called the JIT, or just-in-time compiler, and that means that it's a system that is can in the middle of being compiled and interpreted. So Julia can take advantage of this compiler it has. So you are speeding up your things. The syntax is super simple. It's very similar to Python. If you go there and just check their web page and find an example, if you know Python already, it's gonna be super simple to understand, like the differences and the similitudes between the two of the languages. One of the other cool things about Julia is that it's been funded by a lot of great companies, organizations, and schools. So it's going to be more important in the future. So if you want to be there and you want to be on the top of the future, you should take a look on Julia. Another language that it's getting more and more important is Go. And someone here mentioned that, Salvador mentioned here Go. Go is a language that is actually very interesting. One of the cool things is that if you know C++, it's going to be very simple for you to learn Go. It has the same spirit. It's a language that you can create like these objects and all of these things, and it's a very good alternative for if you want to speed things up to C++. And it also has a whole ecosystem for data science. One of the things that you can see is Gota, Gota. Those are data frames for Go. You have Q frames that are immutable data frames for Go. We have GoLearn, that is a machine learning library for Go, and a lot of the things right now underneath, like web pages and web frameworks, they have Go underneath. So it's also good for this combination between the web and the offline world. There are two books that I think of that can help you learn Go in the world of machine learning, and they are by the people at Pact. So if you search online for machine learning Go Pact, you'll find some books for that. And they also have a good community. They also have a good community for the world of data science. By the way, this list is not in order. I mean, the only thing that was in order was Python and R. That I'm gonna go back there. I just want I just want to talk about different languages, but the most important ones are Python and R. The other ones, they don't have a preference so far, because if you were to ask me my other preference on the top of aside from R and Python, it's Scala. Scala is a language that was supposed to be the future of data science 5 years ago. When I was starting in the world in data science, when I was starting in the world for data science and machine learning, that was in 2013, 2014. I remember that I started studying Scala because I was really into functional programming and Spark back then, and I think everyone was talking about that Scala was gonna was gonna go over R, because Python at that time was important, but not as important as R back then, like 6 years ago. And so Scala was supposed to be this language that was gonna go there and replace R in the world of data science. That didn't happen. I think a lot of us, when we were studying 2013, 12, 14, we all thought that Scala was going to be it, because Spark was written in Scala, and you have a lot of different libraries like Breeze, Saddle. These are great libraries for machine learning, and we thought that people were gonna go there, and like the whole community of machine learning was gonna go to Scala. That didn't happen because of several things I'll discuss here. But even though Scala is still a very important language, you have a lot of things that are easy. I mean, if you need to choose between Java and Scala, and Java is a language that I can say that it's important, I personally don't like it, but because a lot of the things you can do with Java, you can do with Scala. So if you have to choose between learning Java and Scala, and you are a data scientist, maybe you should be choosing Scala. Also, because a lot of the frameworks for big data, like Spark and stuff like that, they're written in Scala, and it's actually a very interesting language. It's not that easy to understand as Python or R because it has some technicalities there, but I think it's a good language, and if you have the chance, you should check it out. Again, if you want to know more about Scala, there's a great course on Coursera by the actual creator of the language, and you can find that online, and it's free, I think, right now, and it's a set of 5-6 courses that takes you from the basics of programming, of functional programming, through the world of Scala and all of this into Spark and machine learning. So I think it's a very cool course. Someone's asking me about books for Julia. I don't really know books for Julia. I know that they have a great community, and I think what I can recommend right now before going into the books, because this is a very changing. I mean, Julia is a language that is being developed at this moment. So it's not that easy for me to say check this book, because maybe in 6 months it's not going to be relevant. So I think the best thing you can do is check their webpage. They have a good blog there, a good community, and when you click on the learning section, you have tutorials. There are some books there. I mean, someone here saying that you have something called hands-on design patterns and best practices with Julia, with Pacts again, and you have at least 25 books here. Some of them are very old books, like 2014, 15. I don't think those are relevant anymore because the language has been changing a lot lately. One of the other things I can recommend is that you watch the JuliaCon. That's the biggest conference we have for Julia. I think the last one happened in Baltimore last year. So the videos are free to watch on YouTube, and you'll find there a lot of different applications you can do with Julia. Another language / system I can recommend is MATLAB. Someone said talk about MATLAB. The only thing I don't like about MATLAB is that it's not free, and that will place it in the same spot as SAS for me. So MATLAB and SAS, they are good systems. Some people, I think a lot of people are using them in the companies because they trust their developers. It's a system that you have to pay for, so you're trusting a whole company underneath the language. And actually, if you check the story of Python, things like scikit-learn, things like pandas, and things like matplotlib, they really come from people in the MATLAB world trying to create or develop an open source way of working with MATLAB. So if you know Python and you have the money to pay for it and you buy MATLAB, I think you'll find that it's a good system. It actually has a lot of great things for data science, for machine learning, for deep learning, for neural nets and graphs, and all of these things are very well developed in MATLAB. But I'm not going to say that much more about it because it's a system that is a paid system, and I'm going to be focusing here on programming languages that are free to use. The other thing that you need to understand and you need to know is SQL or SQL. I'm not entirely sure you can call SQL a programming language per se, because this is a language that is maybe in the same, is like similar to what you think that you can do with data frames in Python or in R, but it's only a data related system. So you can only work with data in SQL. You cannot create whole programs or whole algorithms with it. So it's still important, because I think most companies in the world are still using SQL. I mean, the whole world of NoSQL, it's important. The world of graph databases, it's very important. We'll go there in next sessions. But I think if you really want to succeed as a data scientist right now, you need to know SQL. I think it's the only thing you cannot not learn. It's the only thing that it's very important, because when you go to a new company, the first thing you will have to do is to go to your database, see the data, perform some queries, bring the data back to your computer, do more queries, and that's the way you can understand the data. So I think it's very important. It's very important. There are other languages that are close to data science. The other one is JavaScript. I think JavaScript is it's a great language for working for the web. It's a very weird language. I will not recommend anyone to learn programming with JavaScript, because the problem with that is that you will be learning a lot of bad practices. JavaScript is a language that is very free, so you can almost do whatever you want with the language, and that's not the case for almost every other language. So you will be taking a lot of bad things from JavaScript into the other language or want to learn. But it's still important, because if you really want to scrape the web, or you want to create dashboards with R or Python like Dash and Shiny, there you will be finding a lot of JavaScript things that you will need to know and you will need to understand before being able to use those libraries. So I have a question here saying, what do you recommend to learn for data science? Do I need to take an algebra class? So this is a question from a different session. If you go there and watch my session on the math of data science, you'll find that algebra is a very important thing if you want to be a data scientist. And also calculus, and also statistics and probability. And I have an article, I think that was 2 sessions ago. I have in the newsletter, you'll find 38 resources to learn math for free. So make sure to check the newsletter. It's on my profile. You can go to my profile on here on LinkedIn and search for my articles, and there you'll find the newsletter, and you'll find a lot of different resources to learn algebra. I have another question here from Christian saying, how much time do we expend? How much time do you should be expending learning all of these languages? So this is a very good question. I think one of my favorite articles in the computer science world is a very short blog post by Peter Narvik. Peter Narvik is the director of AI in Google, and the article is called something like "Learn Yourself How to Program in Only 10 Years." And the spirit of that article and blog is that you know and understand that programming is not an easy task, and you will be spending a lot of time learning how to program. And if you want to be an expert in a language, that will take a lot of years in practice. I can say that if you really want to get into an easy language like Python or R, you can spend 6 months with a good course, and you will be learning a lot. If you really want to master a language like Python or R that are in the simpler part of the spectrum, you will be needing at least a year or two practicing almost every day to be able to really master the language. For more complicated things like Scala, C++, Java, that will take you at least 3 to 4 years to really understand the language. And because there are a lot of things that are not that easy. I mean, I'm not saying here that if you want to learn Scala, you will need to wait 3 years to get started. No. I mean, if you get started in the learning of a language, in just a few weeks, months, you will be writing code. It's not going to be that hard. The complicated part here is to really master and understand these languages. If you want to learn SQL, I think you can learn SQL easily, like the easiest part, the easy part of SQL in around a month or two. If you want to be more specific with your queries, I think that will take you at least 6 months to a year to learn SQL. So I think my recommendation here is that if you really want to learn programming, you should be enrolling into a computer science degree. I mean, spend 5 years of your life learning how to program. And I mean, you will not be only spending 5 years. I mean, I graduated several years ago and I'm still learning every day. I mean, I've been programming for the past 10 years or even more, and I'm still learning how to program every day. So there are a lot of things you need to relearn all the time to be able to keep in the state of the art. We have another question here. Do we have to learn all of them? Is there a priority? Which you can say are the basics? So I think the basics ones are Python and R. You know that you'll find thousands of courses online, both for free, certificate courses, and even degrees that can use Python. So I will maybe in the future sessions I'll discuss more on how to learn specifically Python and R. But if you really don't have that much time in your life right now, I think I can recommend that you learn Python if you want to learn how this, like the big picture of programming. If you're a person that's working with financial data, social data, something like that, I think R is a good fit for you. R is a very simple thing to understand and know. And so I think if you are in the world of like financial data, I think it's a better fit for you than Python. I mean, if it were for me and I was starting to learn, I will learn at both. Not maybe at the same time, but maybe spend some months in Python, spend some months in R, because both of them have, they have good things. And I think plotting in R is super simple and useful. And the whole programming world is very simple with Python. And so you can take advantage of both of them. We have a good question here. Is it better to use Scala instead of Python for PySpark when working with Spark? So this is a very important question. So if you're using Spark and you're using the data frames API, there's no difference. The people at Spark, I think beginning in Spark 1.6, something like that, I don't even remember. You're not gaining speed. You're not gaining speed if you're using Scala over Python or R, because if you want to learn that, because if you go to the internals in Spark, you have something called the Catalyst, and the Catalyst is a system that can help you build code for data with Python and Scala and Java and R with Spark at the same speed. So you're not missing anything if you're using Python with the data frames API. But if you're using the RDD API that you should not be using at this point, you're gonna lose some computer power there. So I really recommend if you for some reason need to use RDDs in Spark, you will need to go to Scala. But for most cases, you'll be good with Python. There are older languages, and I know some of the people watching this may think, what about BASIC and Fortran and Visual Basic and Fox Pro? So all of these languages, they had their time, and they were very important for the world of scientific computing and all of these programming world, but it's not a time to start learning these languages like COBOL or Pascal. I mean, I learned them when I was studying back in 2009, and they were old already. They were very old languages already. So 10 years from there, we are here in 2020. There's no point for you to learn those languages. I think you should. I mean, you should stick to the list I gave you here. I'm gonna repeat it: Python, R, C++, Go, Julia, Scala, SQL, and others like JavaScript, Java, something like that. I think if you are very like ambitious, you can learn at least 5 of these languages in 2-3 years. But there's no point to keep learning the languages like Fortran or stuff like that. I mean, if you're a physicist working in a school and you're an astronomer, I really understand you, because a lot of the things you have to use are written in Fortran. So I know you. I was there. But there are ways of re-implementing these things in easier languages and take advantage of new computer power we have. I have a question here about Alteryx, and I think the question is about these drag and drop things. So there's a lot of options. If you don't want to learn programming, there are options like Alteryx, Data IQ, RapidMiner, and all of these things that you would drag and drop into the system. And you also have that on SAS Miner as well. So when you have all of these tools, I think the only problem with that is that, okay, I mean, I would recommend that if you know programming. Because if you know programming, you're okay. If something does not exist in these packages, you can just take that and do it on your own. But if you only know Alteryx or Data IQ or SAS Miner or something like this, you will be stuck there forever. You will not be able to stay in the state of the art. And also, even though those packages have connection with Python and R and all of this, I think if you were to ask me, you should be learning programming instead of drag and drop things. The last thing I want to talk about are the trends for these next years, and I think Python is going to stick into the top for the next years. So you should be learning Python if you want to get a job in data science. I think Julia is going good, and it's going to be more important. It needs more people there. It needs more people in the community. I think R is going to fight, but it's not going to win. So I think a lot of the people using R are going to be moving into Python in the next 5 years. I mean, this is just a speculation. I don't know if someone it's going to create a library it's going to change everything for the R world. I don't know about that. I also think that C++ is not going anywhere. So if you have the time, learn C++. If you want to be able to take advantage of GPUs and stuff like that, and like NVIDIA and CUDA, you really should be learning C++. And the other trends, I think, is that the world of programming for machine learning it's gonna move a lot more into Python. I think TensorFlow, PyTorch, they're leading the way in the world of data science and machine learning. Most of the papers right now are written in Python and in PyTorch or TensorFlow. So you should be learning those libraries as well, because it's just going to get bigger and bigger, and you want to start as soon as possible, because it's going to be hard to do it in the future. So with that, I finished my session. Remember that this is going to be on YouTube as a video. Hopefully tomorrow you can watch that on the Closter team channel. Just search for Closter on YouTube and you'll find it, or search for Data Science Now Closter on YouTube and you'll see it. And also, this is also being posted as a podcast. It's gonna be posted as a podcast on Spotify or and also in Google Podcasts, in iTunes, and all of these places. And also the newsletter is coming. We have one pending newsletter from last week, so I think the next newsletter may be containing material from these two last sessions. I'm not sure about it. Make sure to follow me on here on LinkedIn to see next versions of Data Science Now, and also follow Closter at Closter Team on Twitter or Instagram, or Closter in here at LinkedIn or Facebook. Thank you very much to my team, Gabriel, Eileen, and Hazel, to help me for helping me creating these sessions. And I'm gonna see you next week. Take care.